On-policy distillation is rapidly becoming standard for post-training large language models, but it's notoriously unstable. Why? Because we've been treating it like traditional knowledge distillation, when it's actually an exploration catalyst. OPD minimizes reverse KL divergence by using a stronger teachers per token log ratios, as dense rewards across the student's own rollouts. But here's the catch. It doesn't expand the student's capability ceiling. It just accelerates how quickly the student surfaces correct reasoning paths already within its inherent reach. That means if the guidance signal is flawed, OPD doesn't just plateau. It actively accelerates convergence toward degenerate solutions. First, student-teacher mismatch. The assumption that a stronger teacher always yields a better student breaks down when the distributional gap is too wide. The teacher's token-level preferences decouple from actual rollout correctness. The signal becomes anti-correlated with task accuracy, and the student optimizes for noise instead of logic. Second, length exploitation. Because OPD aggregates token-level advantages over variable-length sequences, it creates structural shortcuts. The student learns to pad responses with low-information filler tokens to dilute negative advantages, or truncate early to lock in high-confidence prefixes. The optimizer gets rewarded for gaming sequence length, not improving reasoning fidelity. To fix this, we don't need bigger teachers or off-policy replay buffers. We need in-loop signal regulation. Two lightweight methods work effectively: hard clipping, which bounds extreme log ratios to eliminate pathological outliers, and soft log scale compression, which preserves the teacher's full token ranking while dampening unbounded magnitudes. The critical insight: when the teacher-student gap is large, hard clipping stabilizes training by aggressively truncating distributional noise. When they're capacity matched, log compression preserves fine-grained preference signals. Regulating the optimization signal, not scaling the teacher, is what actually governs distillation success. If you want the full mathematical breakdown and benchmark tables, check the paper. Let me know in the comments which regulation strategy you'd deploy first.